knowledge. We're going to talk about composition and decomposition. Okay, so we're going to first start by defining what is composition. And so we're going to start with this notation, f of g of x. So this little open circle means of, f of g of x, and you can also think about it as f of g of x. Okay, so I have two functions. I've got an f of x and a g of x, and this is saying I'm taking g of x, whatever it happens to be, and substituting it inside of f of x. Okay, so just like when we combine functions, I'm going to adjust this just a little bit, yep. We had to think about the domains of the two different functions. We have to do that here too, but in a different way. Here we need to think about first, what are restrictions on the inner function? Okay, so in this case, it would be on g of x. And then you would want to think about any restrictions that occur on the composed functions. Okay, so those are the two things that you need to do when you're looking at domain of a composed function. Okay, so we're going to look at these functions and we're going to compose them in a couple of different ways. The first thing we're going to look at is f of x, g of x, and h of x. These are three separate functions. And when we look at a composition like this, we're going to take the inner function, and let's just rewrite it in the other format, okay? G of h of x, okay? Which means I'm going to take h of x and substitute it in for g. So you may even want to rewrite it in that way. What is h of x? Well, we know h of x is 3x plus 1. So we can say we're really taking g of 3x plus 1. Okay, so what we're going to do with that is we're going to take that 3x plus 1 and find our g function. And where we see x, this is going to be replaced by 3x plus 1. So what does that look like? It looks like 5 divided by 3x plus 1, where that x was, minus 1. Okay, so now let's clean it up just a little bit. Okay, so we would have 5 divided by 3x plus 1 minus 1, just 3x. Okay, so this would be g of h of x, 5 divided by 3x. Now we need to consider our domain. And to consider the domain, we want to think about any restrictions that we have on the inner function. So our inner function, what is the domain here? Let's see, no fractions, no radicals, no logarithms. Our domain here is all real numbers from negative infinity to positive infinity. So no restrictions, which is nice. But then we look at our composed function here, and we think to ourselves, what issues might we encounter here? We have a fraction. We don't ever want to see 0 in the denominator. So we're going to think about, okay, denominator cannot equal 0. That means x cannot equal 0. All right, and then we would say in interval form, that would be from negative infinity to 0, union 0 to infinity. So now let's look at h of g of x. Again, h of g of x, right? Or in other words, this is h of this thing, right? G of x. 5 divided by x minus 1. Okay, so now we need to take this thing and substitute it into this thing where we see the x. Okay, so that would be 3 times 5 over x minus 1. That's substituting that expression in for x, and then we're going to add 1. So let's clean it up a little. Remember, when we're multiplying a fraction by a whole number, it's the equivalent of, putting it over 1. And so now we would have 15 over x minus 1 plus 1, which is the correct answer, but often when you have a fraction and a whole number, we want to put it in a single fraction. When you add those things, remember you want to have a common denominator. Okay, so we would multiply this whole thing by x minus 1 times x minus 1. Well, 1 times x minus 1 times x minus 1, or over x minus 1, right? And so we would end up with denominator is x minus 1, and then I'd have 15 plus x minus 1. So I think that would be x plus 14. All right. Okay, so now let's think about our domain. What restrictions are on our inner function? Our inner function is g of x. Our inner function has this restriction, let's see, x minus 1 in the denominator. Remember, we think x minus 1 cannot equal 0, x can't equal 1. That's our restriction for our inner function. Okay, now let's look at our composed function. Over here, same restriction. So our domain is x can't equal 1. All right, so x domain, x is not equal to 1. In other words, negative infinity to 1. Union 1 to infinity. Okay, last example here, g of f of x. Again, helpful to write it, g of f of x, right? Or g of f of x is square root of 2x minus 1. All right, and so we're going to take this expression, the square root of 2x minus 1, take it to the g function, and just substitute it where that x is. So we would end up with 5 over square root of 2x minus 1 minus 1. Okay, not a whole lot we can do here unless we want to rationalize the denominator, which we don't really need to do. We can just leave it like this. But we do need to think about our domain. So first think about the restrictions on our inner function. What is our inner function? That's that square root of 2x minus 1. So remember, we would want our radicand to be positive. We would make this greater than or equal to 0. And so x is greater than or equal to 1/2. Okay, otherwise known as, from 1/2 to infinity. Okay, so one of the restrictions on our domain is x has got to be bigger than 1/2. The other thing is we can't let this thing be equal to 0. So we can't let our denominator here be equal to 0. So we're going to say the square root of 2x minus 1 can't equal 0. All right, so the square root of 2x minus 1 is not equal to 1. Squaring both sides, we would have 2x minus 1 can't equal 1. Add the 1 to both sides. 2x can't equal 2, which means x can't equal 1. Okay, so now it gets just a little bit interesting. All right, so we're going to think about the restrictions that we have. We know that our domain starts with this restriction, 1/2 to infinity, right? But we also know that x can't equal 1. So we have to go over here to 1 and take that out of our domain. Okay, so then we have to interpret this as an interval. Well, here's a piece of an interval, and also here's a piece of an interval. So we have really from 1/2 to 1 union 1 to infinity as our domain here. Okay. We're going to switch gears and go to decomposition, otherwise known as Walking Dead math. You'll find that this is pretty easy. We're going to take functions apart that have already been composed. Okay, so let's say that we've got this case where f of g of x is equal to h of x. Okay, so remember we talked about this could also be written as f of g of x is equal to h of x. So you may be asked to take a function, which is h of x, and rewrite it in terms of f of x and g of x, where f of g of x is equal to h of x. That sounds really complicated, but it's really not. All we're looking at is thinking about f of x and g of x as the two parts of the function. G of x is the inner piece of the function, or just the inner function. F of x is what's left, the outer piece of the function. Okay, so we're going to think about a couple of examples. Okay, so let's look at this example. F of g of x is equal to absolute value of x cubed minus 1. Now, if you look at this, you can see that there's one thing inside another thing. Okay, and so what we want to think about is what is inside something else. Well, you see this? It's inside something else. That x cubed minus 1 is inside. So that becomes our g of x, the inner function. So I'm going to write that down here. G of x is equal to x cubed minus 1. Now, you want to think about your f of x being what's left. What's left if I take this out? Well, absolutely, that's a math pun. We have absolute value. But you know what? When you have a function of x, you need a variable, which we know to be x, and we just put that x right there. Now, if you think back about this, if I took g of x and put it in f of x, I would be taking this and putting it in this, which would give us where we started. And that's exactly what we. The last two examples for decomposition. So take a look at this one. If I look at this one, I see that there's something inside something else. Here's the inside function right here, right? So we can say that I'm looking for f of x and I'm looking for g of x. G of x is the inside piece. In other words, it's 2x minus 3. What's left? I've got something being cubed. That something is our variable, x cubed, and we're good to go. Over here we have the square root of x to the 4th minus 17. Well, again, what is the inside piece? That will serve as our g of x. The inside piece is what's inside the radical, x to the 4th minus 17. The f of x is the outside piece. What's left? Well, we definitely know that's the square root of our variable, which is x. Okay, so that will wrap up decomposition, and I'll see you in class tomorrow.